Hi, hello, welcome to another exciting math lesson. Today we're going to talk about geometric theorems and proofs, kind of go about how we would go about those. So during this lesson you're going to learn how to use coordinates to prove geometric theorems algebraically. Vocabulary, the good chunk of this lesson is going to be vocabulary, and we'll kind of get into a proof and how we go about them. To bisect is to divide or create two equal parts. There's the key part there. A bisector is the actual item or line that divides another line or object into two equal parts. Perpendicular is two lines that create a right angle, which is 90 degrees at their point of intersection. Okay, so perpendicular bisector. It's a line that not only bisects an object or another line segment, but it's also perpendicular to that line. So notice right here is my perpendicular bisector. It's the item that cuts something in half, but it also does so that it creates a 90 degree or a right angle. Okay, and same thing here. There'd be my bisector, perpendicular bisector. An angle bisector is a line that bisects the angle of a triangle and connects to the opposite side. So notice I'm cutting this angle in half when I bisect it, okay? Parallel means two lines that never cross or touch, and they share the same slope, which we know as rate of change. An altitude is a line that passes through an angle of a triangle and is perpendicular to the opposite side of a triangle. So notice I'm not bisecting anything here. This is creating an altitude, which we use to find the height of an object. Okay. Diagonals of polynomials. It's a line inside a shape that connects one corner to another. So we can have all sorts of diagonals of polynomials. A median is a line that passes through an angle of a triangle and bisects the opposite side. So there's the key, is it bisects the side, the opposite side of the angle. So I don't know if my angles are bisected. I'm not sure about that. All I know is that those sides are bisected. No, I just want to move slides. Okay, there we go. Midpoint is the point that is the halfway mark on a line or an object. So right there. The Pythagorean theorem, we've talked about this a lot. You've talked about it a lot. It's an equation that helps to solve the side lengths of right triangles. Okay, the distance formula is another version of the Pythagorean theorem. We've talked about it already. You've talked about it. That helps us find the distance. We have a little formula here that derives it. We can say that my A, so this leg right here, is x2 minus x1. My height here, this other leg, is y2 minus y1. The Pythagorean theorem is a squared plus b squared. We substitute in my a and my b in for solved. D squared equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we take the square root of that. Okay, the radius is the distance from the center of a circle to any point on the circle. Center is the middle point of a circle. The diameter is the longest chord that can be created in a circle, and a chord that passes through the center of the circle is twice the radius. Okay. Inscribed just means a figure drawn within another figure, such that they touch but do not cross, so they just barely touch at these points right here. Okay, so a proof. You can use facts that you have learned to prove that things are true. So proofs usually have two columns. The first column has things that you're saying are true. So you're saying, this is true. The second column is the reason why you know those things. So it's mainly this reason part. Okay. So let's look at this. So it says, prove that the coordinate points 3, 3. So we're going to mark all these points here. 3, 3, 7, 3, 3, 5. Oh, 3, 5. What am I doing? Not 0. 3, 0. So we got 3, 5, and 7, 5. And you're saying, well, of course, this is a rectangle, right? So we're saying prove that these points create a rectangle. All right. That's pretty easy. We know that's a rectangle, but we'd have to state why. So what I'm going to do is I'm going to create some labels. I'm going to say A, B, C, D. I'm going to say that A, B is congruent to C, D, which tells me, and AC is congruent to BD. Okay, so we're going to kind of create two columns here. And this is just by measurement, right? We just figured out the measurements here. Okay, and then we can say that AB is parallel to CD, and AC is parallel to BD. That's because we could say shared slopes. Then we can say that AB is parallel to AC. We could say negative reciprocal slopes. So this one's easy. If I was like at an angle, so if I had like something like this, you'd have to take the slope of each of those lines and be able to do this. And then we could say that A, B, C, D is a rectangle. And we just say by rectangle definition. Okay, so I have two pairs of parallel sides, two sides of perpendicular sides. We could do the same thing with BD is perpendicular to CD. And that would all work out. Okay? Okay, so it says use coordinates to prove circles. And this is the main one that's going to be on your guys' quizzes. So it says give a circle with center -1, 3. So we have -1, 3. It says determine whether or not the points -3, -1. So I'm going to do these in different colors. -3, -1, and 4, 5 are on the same circle. So if this is my center, I know that if both of these points are on the same circle, they should be equidistant, meaning the same distance away from my center point. So in some of these, your questions, it's going to be very easy to know if they're the same distance, and other ones you're going to be like, I don't know. This one, it could be, they look like they could be on the same circle, but they very well could not be. So what we're going to do is we're going to actually use the distance formula to solve this. So I'm going to go over 1, 2, 3, 4, 5, and up 2. So we'll do this in green so we can tell. We're trying to find this distance. I'm going to say the distance equals the square root of, so we kind of did, we could have used the points. I counted because, well, we could because I have the graph here. I'm going to say 5 squared plus 2 squared. I'll do the distance formula on the next one. The true distance formula. 25 plus 4. Distance equals the square root of 29. Okay. And then for the red one, so with the red one was my center and -3, -1. Okay. So the distance equals the square root of -1 minus -3 squared plus my y's 3 minus a -1 squared, because distance equals the square root. -1 plus 3 is 4, so I get 4 squared plus -1 plus 4 would be 3. Wait, -1 plus 3 would be 2. 2 squared. 3 minus negative 1, 3 plus 1 would be 4. Okay, so I get the distance is equal to the square root of 4 plus 16. Distance equals the square root of 20. So notice those are different. So we would say not on same circle. 1, 2, 3, 4, 1, 2. Yep, we got all those. Yep, so it's not on the same circle. It's really close, but not quite. Okay. All right, so now you try. True or false, given a circle with center of 2, 7. 2, 7. So there's my center. And then I have the points 4, 11 and 0, 3. Oh, let's change colors there. 0, 3. Are those on the same circle? So we said 4, 11 was green and 0, 3 was the red. Okay. All right. So my green distance is equal to the square root of, we'd say 2 minus 4 squared plus 7 minus 11 squared, which is equal to the square root of negative 2 squared plus negative 4 squared. Square root of 4 plus 16, and we'd get the square root of 20. Okay, so there's that one. Then we'll do the red over here on the right hand side. I'd say my red distance is the square root of 2 minus 0 squared plus 7 minus 3 squared. So I'm just taking my points in here and plugging them into my distance equation. It's equal to the square root of 2 squared plus 4 squared. Square root of 4 plus 16, which equals to the square root of 20. These are the same, so they are on the same circle. So we are same circle. Okay, let's try again. So we have 5, negative 1. There's my center. 13, 6. Okay. And negative 2, negative 8. Whew, those are pretty close. I don't think they're on the same circle, but let's look. Now we'll start with our red. We're already on there. So I'd say, okay, so I'd say my red distance is the square root of 5 minus a negative 2 squared plus negative 1 minus a negative 8 squared. Don't know why I have that comma there. Okay, so I get the square root of 5 minus negative 2 is 7 squared plus negative 1, oops, so we have negative 1 plus 8, which would give me a negative 7 squared, which is the square root of 49 plus 49, which equals the square root of 98. Okay, does that make sense? 1, 2, 3, 4, 5, 6, 7. Okay, we're good. So square root of 98. Let's do the green one. As the distance equals the square root 5 minus 13 squared plus negative 1 minus a negative 8 squared. Okay, 5 minus 13 gives me 7 squared, or negative 7 squared, plus negative 1 minus negative 8 is negative 1 plus 8, which would give me 7 squared, and we can see this is coming out really nicely for us. So we'd say on same circle. That's what all the quiz is. Just doing stuff like that. If you have any questions, please come talk to me. I'm happy to help you out. Have a great day. We'll talk to you later. Thanks.